How do network devices and applications communicate with each other? How do they establish understanding and seamless interaction? Hey everyone, welcome. In this video, I'm going to give you a quick introduction to the OSI and TCP IP models. No boring descriptions here. If you're interested in hands-on networking learning, stick around and watch this video till the end. Let's get started. In the classic world, every successful communication relies on specific rules, standards, and regulations. This principle extends to our daily lives as humans within our local and international societies. Similarly, network devices and applications must adhere to certain rules and standards for successful communication. One of the series of rules and standards is the TCP/IP model. In this model, rules and standards are typically broken down into 4 layers, although in some documents a 5th layer is also discussed. By learning these rules, we can understand how devices and applications communicate over the network. This knowledge is our magic weapon to design, implement, and troubleshoot them. Moreover, with a little creativity, we can use these rules to create our devices, applications, protocols, and technologies. Why not? On the other hand, my friends, without understanding these rules, we don't have any chance to control and manage our networks. It's like driving on a busy highway with closed eyes. For better understanding the TCP/IP model, let's see what if there's no networking model exists. Back in the 1970s, big IT leaders and vendors has their own networking model. It means if a company needed to use different vendors' computers, it should use different standards for each. Those days, the use of network was not as widespread as it is today. Think about that for a moment. If this situation continued, how we can face with our today's requirements, issues, and problems of networks and applications. Imagine you're in charge to manage and maintain a network include multi-vendor devices and applications like Cisco, Juniper, Arista, Big IP, and others. And in the context of operating systems and applications, Microsoft, Apple, IBM, VMware, and others. This is true for hardware vendors and so on. How they can communicate without one integrated and comprehensive blueprint. Fortunately, smart people have already thought about it and reached a comprehensive and efficient solution. In the 1970s, the International Organization for Standardization, ISO, started to work on creating a blueprint that all vendors could use to develop their products and technologies based on that. This blueprint is known as the Open System Interconnection, or OSI. It works like a template for IT vendors in all contexts, including network devices, operating systems, applications, and hardware. As ISO continued to work, other scientists came together under a project ordered by the U.S. Department of Defense, or DoD, to create a public networking model that nowadays we know as TCP/IP. After a while, companies started to use both models until TCP/IP won the battle by the end of the 1990s and become the common choice as the only networking model. Since then, we use the TCP/IP model everywhere. Let me clarify the usage of the TCP/IP model with some basic and simple examples. Imagine you want to assign an IP address to a device to connect to the network. It doesn't matter what type of device it is. Assigning an IP address follows the same rules on all types of devices and operating systems. In another example, if you're somehow familiar with VLANs, you configure VLANs on each network device using the same rules, and they understand what a VLAN is. In another scenario, imagine you want to connect different devices from different vendors to an Ethernet LAN. You simply plug them up into the switch, and they know what Ethernet is and how to communicate based on this type of network. Now, the only thing you need to do is to understand how this blueprint breaks down rules and categorize them into multiple layers to interconnect network components. This way, you can master the network and ride it like a bicycle. Now we know why we should have a network model, and we know TCP/IP has been chosen as the ultimate model. So it's time to briefly delve into the details of this model and its layers, rules, standards, and protocols. But before that, you may ask, wait a minute. There are other organizations and companies that work on the standards, like IEEE, IETF, IANA, and others. Now, one of the questions is, what do they do? Where do they come into play in the networking world? And what is their place in this world? Another question might be, you say TCP/IP has become the ultimate networking model, okay? But we still hear and read about the OSI model. Is it really gone, or does it still persist? These are important questions, so let me answer them one by one. To address the first question, let's look at the definition and rule of each one. TCP/IP. TCP/IP is defined as a protocol suite that forms the backbone of the Internet. It includes protocols like TCP, IP, UDP, and others. On the other hand, the role of TCP/IP is to provide the fundamental set of rules and conventions for communication between devices on a network. It ensures data integrity, routing, and other key aspects of Internet communication. IEEE. IEEE is defined as a professional association that develops standards for a wide range of technologies, including networking. Its role is to provide standards for various networking technologies such as Ethernet or IEEE 802.3, Wi-Fi or IEEE 802.11, and more. These standards ensures interoperability and compatibility among devices for different manufacturers. IETF. IETF is defined as an open international community of network designers, operators, vendors, and researchers concerned with the evolution of the Internet architecture and the smooth operation of the Internet. Its role is to develop and promote Internet standards, including protocols, procedures, programs, and concepts. It works on protocols like HTTP, SMTP, and others that operate at the application layer. IANA. IANA is defined as a function and a set of protocols that assign and coordinate globally unique names and numbers for Internet protocols. Its role is to manage the allocation of IP addresses, domain names, and protocols parameters. It plays a crucial role in maintaining the stability and integrity of the Internet's addressing system. In summary, TCP/IP is a protocol suite defining the rules for communication on the Internet, while IEEE provides standards for various networking technologies. IETF develops Internet standards and protocols, and IANA manages the allocation of Internet resources. Each entity contributes to the overall functionality and standardization of the Internet and networking technologies. A quick note. To avoid repeating work and conflict between what is already done by other entities and TCP/IP, the TCP/IP model simply refers to standards and protocols created by other entities, such as 802.3, which is defined Ethernet LAN by IEEE. One other quick note. My friends, to define a protocol, these entities use documents known as requests for comments, or RFC. RFCs provides a structured and open framework for developing, documenting, and evolving Internet standards. They contribute to the openness, transparency, and interoperability of the Internet, benefiting the global community of users, developers, and organizations involved in Internet technologies. Okay, well, I won't go into further detail about RFCs since, at the CCNA level, you do not need to know more about them. However, if you're curious, you can visit the official website for RFCs at rfc-editor.org. On this site, you can find the complete collection of RFCs, search for specific RFCs by numbers or keywords, and explore categories and topics related to Internet standards. The RFC editor, supported by the IETF, manages the application of RFCs and maintains the official repository of these documents. So, if you're interested in a specific RFC or want to explore the latest developments in Internet standards, the RFC editor's website is the go-to resource. Okay, my friends. To address the second question, which is about the OSI model and the reasons to mention it in documents and the networking world, I should say it is because of terminology, Don't forget, OSI and TCP/IP had a long battle that lasted until the early 1990s. So many vendors and protocol documents use terminology from the OSI model. The OSI model is still relevant and widely used as a conceptual framework for understanding network protocols and communication. While the TCP/IP model has become the dominant and practical standard for Internet communication, the OSI model continues to persist, in educational settings, discussions, and certain industries. Here are some reasons why the OSI model continues to have a presence. Educational purposes. The OSI model is often used in educational settings to teach networking concepts. Its layered structure provides a systematic way to introduce students to various aspects of networking, starting from the physical layer up to the application layer. Reference framework. The OSI model serves as a reference framework that aids in discussions and descriptions of network protocols and functions. It provides a common language for network professionals and researchers to discuss different layers of network communications. vendor-neutral approach. The OSI model is vendor-neutral, meaning it's not tied to a specific set of protocols or technologies. This makes it a versatile tool for discussing network concepts without being limited to the protocol used in the TCP/IP suite. Troubleshooting and analysis. Network professionals may use the OSI model as a tool for troubleshooting and analyzing network issues. It helps systematically identify the layer at which a problem might be occurring. And the last one, integration with other models. My friends, the OSI model can be integrated with other models and frameworks. For example, it can be used alongside the TCP/IP model to provide a more comprehensive view of networking concepts. While the OSI model remains relevant for certain purposes, it's important to note that in practical implementations, the TCP/IP model is more commonly used. The TCP/IP model aligns more closely with the protocols and technologies that form the basis of the Internet and modern networking. As a result, discussions often involve both models, with the OSI model serving a theoretical reference and the TCP/IP model as the practical implementation standard. Great. With this introduction, we have reached the conclusion of this video. However, the story of networking models doesn't stop here. In the upcoming videos, we'll dive deeper into the TCP/IP layers using a practical and meaningful approach and compare them with the OSI model layers. So, stay with us to uncover the exciting world of networking. If you found the information helpful, I encourage you to subscribe and hit the notification bell. This ensures you're in the loop for our future videos. Liking and sharing this video would be fantastic. It helps us reach more folks interested in these topics. Thanks a bunch for tuning in.